Summarize Chapter 6. First, we looked at the concept that is known as the time value of money. It says that $1 in hand today is worth more than $1 in the future. In other words, the same amount of money has a different value to you today depending on when that amount of money will occur. So for example, if you're offered $100 now or $100 in 20 years, it's the same amount of money, but you're definitely going to pick $100 today. It's sooner, and you can also turn it into more money if you invest it somewhere. Maybe as simple as putting it in a bank account. And after 20 years, it will have so much in interest on top of it. Then we compared simple interest with compound interest. Simple interest is when the interest is earned only on the original amount that you start with, whereas compound interest has more than that. It also has interest on interest because you every year you earn interest on what you have at the beginning of that year, which is what you had at the beginning of the previous year with interest on top of that. So every year your starting point is higher and higher and higher. And so you earn an increasing dollar amount in interest with each year. That's compound interest. First, we looked at the future value. So if you start with some amount of money today, if you know the rate at which it will be growing, such as interest rate that the bank pays on deposits people make, then you can calculate how much you will have after a specified number of years. With simple interest, the future value equals the present value or the starting amount of money, also known as the principal, multiplied by 1 plus r times t. With compound interest, we don't have t in the parentheses, but we have it as a power outside the parentheses. And we say that money gets compounded. So the interest that's earned in the second case, the dollar amount in interest is increasing with each year. Whereas with simple interest, it's always the same interest amount every year. Then we looked at the present value, which is looking at things backwards. Let's say you know how much you will have in the future, and you want to figure out how much you should start with today, so that after growing by a certain rate every year, it will reach that given future value amount after a given number of years. We actually did not have the simple interest present value formula, although it exists. The book doesn't cover it either, so we're skipping it. We only looked at the more realistic scenario, like what we have in real life, with compound interest. To find the present value, we take the future value and divide it by the sum 1 plus r raised to the power t. And we say that money in the future gets discounted. So the present value of something in the future is always a smaller amount of money than that future amount of money. And then in the last part of the chapter, we looked at how we may be given both the present value and the future value, but instead we want to solve for the interest rate. Of course, the number of years between PV and FV should be also known. Then we looked at how we may be given both the present value and the future value and the interest rate, but instead we need to calculate how many time periods lie between the present value and the future value. And this is where we can apply the rule of 72. So the rule of 72 is just to calculate the amount of time. how long it takes for something to double, for the present value to turn into the future value that's twice the present value. Where do we use the financial calculator? Wherever we are using compound interest. So the financial calculator, the special buttons on it cannot be used for simple interest. Simple interest, and we only had it for the future value with simple interest, is only done by hand using the formula. Here's another way to summarize the chapter. In the financial calculator, we learn how to calculate the future value, calculate the present value, calculate the interest rate, and calculate the amount of time. Essentially, we have been working with 4 special keys: PV, FV, N, and IY. First, we looked at how to compute the future value when the other 3 are given. Then we looked at how to compute the present value when the other 3 are given, and so on. So 3 things must be known. The 4th thing in this list is what you need to solve for. Just a quick note about computing the interest rate or the number of time periods. Because $2 amounts at different points of time are known, the present value and the future value. One of them, and it's up to you which one, but one of them must be set to a negative value. Here I show that the present value is where you change the sign to negative, but it could instead be for the future values.